Welcome back to another video. Today we're going to be solving problems 1 to 10 of the 2011 Amc10 A. So let's start. Problem 1. A cell phone plan costs $20 each month, plus 5 cents per text message sent, plus 10 cents for each minute used over 30 hours. In January, Mitchell sent 100 text messages and talked for 30.5 hours. How much did she have to pay? Okay, so let's start. So the by default is $20 for the month. She sent 100 text messages and it costs 5 cents per text message, so it's 500 cents, or that's $5. She talked for 30.5 hours, which is 0.5 hours over the 30-hour limit, which is just 30 minutes. So that's 300 cents because it costs 10 cents per minute. 300 cents, and that's $3. $3 plus, okay, so now we have the $20 base plus $5 plus the $3, which we get a grand total of $28, which is our answer. Problem number 2. A small bottle of shampoo can hold 35 milliliters of shampoo, whereas a large bottle can hold 500 milliliters of shampoo. Jasmine wants to buy the minimum number of small bottles necessary to completely fill a large bottle. How many bottles must she buy? Okay, so a large bottle holds 500 milliliters, and a small bottle holds 35. So we can just basically divide them. So 35. We get 15, 150, and then we can subtract 140. We get a remainder of 10. If we have 14, it won't completely fill the 500 milliliter bottle because we will have 10 milliliters left over. So we need to have one more than 14, which is 15. And so that means we need 15 bottles to completely fill a large bottle. That is our answer. Problem number 3. Suppose A and B denotes the average of A and B, and ABC denotes the average of A, B, and C. What is the expression that follows? Okay, so we can solve the first bracket, which is 110. 110, the average of 110 is 2/3. Next bracket is 0, 1. So the average of 0 and 1 is 1/2. And then the last one is 0. So you have to find the average of these three elements. So 2/3 is just 4/6, plus 1/2, which is 3/6, and plus 0. So this is 7/6 divided by the three numbers that we need to divide by. So the answer is 7/18 is the expression. That's a 3 expression. Okay, problem number 4. Let x be the sum of the even numbers from 10 to 100 inclusive, and y be the sum of the numbers, even numbers from 12 to 102 inclusive. Find y minus x. Okay, so x is the sum of the even numbers from 10 to 100, which is 10 plus 12 plus 14, plus 100. And y, it doesn't say here, but it's actually also the sum of the even numbers from 12 to 102. So that means that y equals 12 plus 14 plus 16 plus 18 plus 102. We can notice that the difference is this is just going to be 2 times the number of elements in the list, because you can see that the number of elements in x is going to be the same as the number of elements in y, because for each element in x, we're adding 2 to that and getting each element in y. So if you find the number of elements in x, that's 100, the last element minus the first element, which is 10. The difference, we get 90. We divide it by 2 because we're adding 2 each time. And then I add 1 to get 46 elements times the 2, that's the difference, which equals 92 is our final answer. Problem number 5. It's a long one. Okay. At an elementary school, the students in 3rd grade, 4th grade, and 5th grade run an average of 12, 15, and 10 minutes per day respectively. There are twice as many 3rd graders as 4th graders and twice as many 4th graders as 5th graders. What is the average number of minutes run per day by these students? Okay, so we can use variables. So let's say there's X 5th graders. For X 5th graders, there's 2X 4th graders, and there's 4X 3rd graders. Okay, so the 5th graders, there's X 5th graders, and they run 10 minutes per day. So we get 10X is the number of minutes they ran. Now there's 2X 4th graders, and they run 15 minutes per day. So then we get 30X. And then there's 4X 3rd graders, and they run 12 minutes per day. So then we get 48X. And we have to find the average number of minutes, so we divide this by the number of students, which is equal to 7X. So then we get that 88X over 7X equals our answer, and we can cancel this out, so the answer is 88 over 7. Moving on to problem 6. Set A has 20 elements and set B has 15 elements. What is the smallest possible number of elements in the union of set A and set B? I think that's a typo there, but anyways, okay. So set A has 20 elements and set B has 15 elements. If the problem never says that the elements can be equal. So let's say set A has all elements equal to 1. Okay, so this is 20 elements, and set B has all elements equal to 1 as well. This is 15 elements. Now, the union will be just 20 because all of these elements are technically equal to these. So, the answer, and the union, by the way, means the intersection of both sets or the number of common elements in both sets. So, the common elements are going to be 20 here. Which of the following equations does not have a solution? So, I don't see any equations, but I think the equations are meant to be as follow. X plus 4 squared equals 0. The absolute value of negative 3x plus 5 equals 0. My best friend. Okay, square root of negative x minus 2 equals 0. Square root of x minus 8 equals 0. And finally, the absolute value of negative 3x minus 4 equals 0. So you have to find which of these equations does not have a solution. So let's start with the first equation. X plus 4 squared equals 0. We can square root both sides to get x plus 4 equals 0 and x equals negative 4. So clearly this one has the solutions. Now for the second equation, the absolute value of negative 3x equals negative 5. But we can see that this is not possible, as the absolute value of something always has to be positive. But here it's equaling something negative, so that's not possible. So this equation does not work. So we can conclude that the answer is this equation. If we wanted to, we could trick the other ones, but if we do, you will find out they all have a root that works. Okay, problem 8. Last summer, 30% of the birds living on town lake were geese, 25% were swans, and 10% were herons, and 35% were ducks. Okay, so what percent of the birds that were not swans were geese? So 25% of the birds were swans. So 75% of the birds were not swans. And we know that 30% were geese. So 30% out of the 75% were not swans but were geese. So that's just equal to 2/5 if we divide 15 from top and bottom. So our answer is 2/5. Or, oh, it asked for the percentage, so that's 40%. A quick way to find the percentage from a fraction is to get the denominator as 100. So 2/5 times 20 over 20 equals 40 over 100. So this is just 40% because the top is the number of percent. Problem 9. A rectangular region is bounded by the graphs of the equations y equals a, y equals negative b, x equals negative c, and x equals d, where a, b, c, and d are all positive numbers. Which of the following represents the area of this region? So we want to find the area of this. So let's draw the x-axis and y-axis first. So the x-axis, y, this is the origin in the middle here. Okay, now let's draw these lines. So y equals a, y is the height, so some a, this line goes on forever and forever. And y equals negative b, so let's say it's like here. This line goes on forever. X equals negative c, this line's here, goes on forever. And x equals d. This line is here, goes on forever. We want to find the area of the area of region that it covers. So it's like this region, that region, yeah. So we want to find the area of that. We know that this is a, the height is a, the height below is b. So the length of this length is going to be a. The length is going to be a plus b because this is a away from the 0, and this is b away from 0, so it's a plus b. And we can do a similar thing for this length of the triangle. We can do a similar thing for this length of the triangle. So that will be c plus d. I want to find the area, so we just multiply our two side lengths. A plus b times c plus d. If we expand this, we will get ab plus bc plus ac. Oh, it's not ab. Never mind, my bad. So it's actually, it's ac plus ad plus bc plus bd, yeah. And that is our answer to problem 9. Problem 10. A majority of the 30 students in Miss Demonor's class bought pencils at the school bookstore. Each of these students bought the same number of pencils, and this number was greater than 1. The cost of a pencil in cents was greater than the number of pencils each student bought, and the total cost of all the pencils was $17.71. What is the cost of a pencil in cents? Okay, so we need to find the factors of 1771. We can take this as basically just 1,771 cents. 71, that's not 7. Okay, so we can immediately see that 11 is going to be a factor because of the divisibility rule. And since 1 and 7 is equal to 7 and 1, the difference will be 0. So you can divide it by 11. Minus 11 equals 67. 66. 111. So it's 161 times 11. Now it's kind of harder. It can't be divisible by any even numbers. And 3 is not divisible by 3. It's not divisible by 5. It may be divisible by 7. Let's see. So 161 divided by 7. 2 minus 14. 21. 3. Oh yeah, 21, 0. So it's 23 times 7 times 11. One of these three numbers represent the number of students in the class that bought the pencils, how many pencils they bought, and the cost of the pencils. The number of students has to be a majority of 30 students. So it can't be 7 or 11, so it has to be 23. So we know there's 23 students. We know that the number of pencils each student bought was less than the cost of each pencil in cents. So that means the number of pencils each student bought is 7 and the cost is 11 cents. The question is asking what is the cost of a pencil in cents. So the cost of a pencil in cents was 11 cents.